In this module, we are going to discuss about iron carbide equilibrium phase diagram. Okay. So if you see on the left hand side, we have pure iron, and on the right hand side we have it is iron carbide, and this iron carbide is nothing but your Fe3C, okay, which is also known as cementite. Okay, right. So now let us see what and all phases that may exist based on different Li composition. Okay, as you all know, this particular Li system is the most important and the very popular Li system in the field of mechanical engineering or materials engineering, simply because you can get different materials, okay, different set of materials based on this particular Li system, which possess different characteristics or different properties altogether. You can have very soft, ductile alloy, a material such as mild steel, or you can have relatively hard material such as cast iron and so on. So let us try to understand various phases that may be existing in this particular Li system, right. So if you see at the bottom of the figure, we have something called steel, okay, and something called cast iron. So these two names predominantly you might be hearing in your day-to-day lives, right? So you may be wondering what is the difference between a steel and cast iron, okay, right? So that is where you got your answer here, okay. For example, if you have what is varying across the x-axis, it is nothing but the percentage of carbon, okay, carbon percentage, right? So what if you have carbon percentage that is less than, okay, 2.1 percentage, okay, what you call them broadly, it is called steel. And if you have carbon percentage that is 2.11 percentage and beyond, okay, you call them cast iron, right? So that's all. That is the only difference between steel and cast iron. But of course, the microstructures may look differently, their properties may be different. In other words, why did we classify them into steels and cast iron? Why they got their names? Why we call, if you have more carbon, you call them cast iron? Why don't we call, for example, steels as cast steels? Okay, something like that. Okay, all these things are something interesting to understand. Okay, but for time being, please remember that if you have carbon percentage up to 2.1 percentage, they are called steels, and if you have carbon percentage beyond that, we call them cast iron. And of course, you have subclassification within steels. Those are, for example, if you have carbon percentage less than or equal to 0.77, then you call them hypoeutectoid steels. On the other hand, from 0.77 percentage to 2.1 percentage of carbon in this particular region, they are called hypereutectoid steels. Okay, why you call them hypoeutectoid or hypereutectoid? Because you have a invariant reaction that is taking place here. Okay, that is eutectoid reaction. Okay, in this particular place. Okay, so in this particular composition, okay, this particular composition is called eutectoid composition because the eutectoid reaction is taking place for the particular composition at this particular temperature. What is eutectoid reaction? Okay, you already know, for example, what is eutectic reaction. Okay, for example, in this particular diagram, we have here an eutectic reaction. What is eutectic reaction? You already know. A liquid is in this particular reaction, liquid is being decomposed into, okay, or forming two solids, right? One liquid is transforming into two different solids. Okay, what are those two solids? So one is austenite, the other one is cementite, right? You can see austenite represented in the form of, okay, in the name of gamma, and cementite with Cm, or you can cementite you can say, or you can use Cm, or you can simply use Fe3C. Okay, so one liquid phase is transformed into two solid forms. Okay, that typically that is called a eutectic reaction. Okay, similarly, here whatever we are talking about now is eutectoid reaction that is taking place, where the only difference between eutectic and eutectoid is the formation of two solids is common, except for the fact that it is coming from a single solid in this case, in eutectoid case. Okay, whereas in eutectic it is coming from single liquid. Okay, here it is coming from single solid. Okay, right. So one solid decomposed into two different solids. And what are they in this case? So they are ferrite, cementite, right? So the whatever reaction that is taking place here, that is giving rise to a combination of ferrite and cementite, and this is called perlite. Okay, now perlite is nothing but it is a eutectic mixture of ferrite and cementite. Okay, so it is as simple as that. Okay, right. Now let us try to see what are the different phases that are existing in this particular system, alloy system. Okay, so since we already talked about say your ferrite, okay, and your cementite, we also talked about austenite. It is important to understand what exactly is ferrite, what is cementite, and what is austenite. Okay, let us try to see that. Okay, and again after that we will revisit this diagram and see what and all existing where. Okay, yeah, this is a same diagram of different rendering. So let us try to start with alpha iron. Okay, in other words, if you take any pure iron, if you see at the room temperature, that is from room temperature to about 770 degrees Celsius, you see that iron exists in the form of BCC. Okay, it will be having BCC crystal structure. Okay, and from of course it will be BCC from 772 until 910 degrees Celsius also, but it will be non-magnetic there. Okay, so that means there is a transition, and the transition is nothing but changing from magnetic to non-magnetic. Otherwise, essentially until 910 degrees Celsius, your iron, pure iron, will remain in BCC form. Okay, but once you reach 910 degrees Celsius, it starts changing to FCC. Okay, so it will change to the crystal system of iron will change from 910 degree onwards to FCC, and it will be remaining in that FCC until 1400 degrees Celsius. Okay, and beyond that, interestingly, it will again get back to BCC. Okay, so of course before it finally liquefies at a particular temperature beyond that. So that means essentially in the solid form, the iron can exist in different phases, isn't it? In the sense, it can have BCC at low temperature, it can have FCC at slightly elevated temperatures, and of course it can have again BCC at very high temperatures. Okay, so to just for our convenience, we will name them in such a way that you can know. For example, when I say alpha iron, okay, what we mean, what I mean is it is BCC iron at low temperatures. Okay, in the sense up to 910 degrees Celsius. So that iron is existing at a temperature below 910 degrees Celsius in the form of BCC is what I understand when I say alpha iron. Similarly, when I say gamma iron, okay, I meant it is FCC. Okay, it is actually FCC, having a FCC crystal system, and it is at a elevated temperature is what I understand. Okay, typically it may be between 910 degrees Celsius to 1400 degrees Celsius. Of course, I may be having iron in BCC also at very high temperatures, and just to differentiate the temperatures in which this BCC is existing, it may, when I say BCC iron, it can be low temperature or it can be very high temperature phase. To differentiate, I call low temperature BCC iron as alpha and high temperature BCC iron as delta. Okay. Now, having known the different phases that iron may possess, a pure iron, we can now try to extend this understanding when we have it alloyed with, okay, iron carbide. Okay, let us see. So yeah, so if you see this phase diagram, you have the at the center, at the top, you see the box where I have defined some of the phases that are present in the entire diagram or in the entire iron carbide alloy system. So gamma is nothing but austenite, alpha is ferrite, delta is delta iron, Cm is cementite. In this you already know, for example, gamma in case of pure iron, what is that? Iron in FCC, right? Right. Then what about austenite? It is also iron in FCC, but in solid solution with carbon. Okay. Now what is austenite? It is a solution of iron, carbon in iron, okay, in FCC crystal system. Okay. Similarly, what is alpha? We call alpha iron in pure iron if it is pure iron, but here we call it ferrite if it is solution with carbon. Okay, that means if it is carbon in iron, it is a solid solution. In BCC crystal system, then we call it ferrite. Okay, similarly, delta iron, we know delta iron at high temperature BCC phase. Even in here, this particular case also, it is nothing but it's a BCC iron at very high temperature. Okay, right? Now, what is cementite? Okay, cementite, as I already mentioned, it is the compound Fe3C iron carbide. We named it as cementite, right? So now you know everything. So now let us see where exists what. Okay, for example, you have gamma here. Okay, that means all this phase, you see, gamma exists. Okay, what does it mean? You take at any given point, if you draw a straight line, okay, vertical line, that represents a particular composition, right? So this composition will be having at this particular temperature gamma, okay, that is austenite. Okay, that means iron and carbon in a solution, and it is having FCC, right? That way, if you take this composition at any of these temperatures, you have gamma. That means it is in the form of austenite, that is carbon in iron in FCC crystal system. Even here, everywhere, all this region, you have a range of compositions of carbon in iron here until here, okay, and a range of temperature vertically in which you have austenite alone, okay. But unfortunately, this austenite is relatively stable at high temperatures. For example, you take any composition and reduce the temperature, as you come down, somewhere austenite is no more existing. It is changing into some other thing, say other forms like alpha or alpha plus cementite or Fe3C. So which are basically stable, okay, stable at low temperatures or room temperature. Okay. So what is alpha? We already know alpha is ferrite. That means ferrite is the phase which is stable at room temperature usually. Okay, generally. Similarly, cementite is also a stable phase at room temperature. Okay, yeah. So now having understood different phases, okay, that may be existing in iron carbon phase diagram, let us try to understand about little more about austenite, ferrite, perlite, cementite, martensite, and ledeborite. With the definitions as well as at what temperature they are stable and so on. Okay, so let me explain all this in the next module.